So in pre-cal, a lot of things just repeat over and over and over again for like infinity in the positive and the negative direction. So anything that repeats forever is called a period. So a function f is a period if there exists a positive real number c such that f of x plus c equals f of t. For all t in the domain of f, the smallest number c for which f is a period is called the period of f. Lots of words, let's just break it all down. First of all, t is your input, x is your period, and the period for us, for a circle, is the circumference. Remember, if you go all the way around a circle, you are right back at the beginning. That's basically what a period is, something that repeats forever. So the period for circles is 2 pi if we're going counterclockwise, or it's negative 2 pi if we're going clockwise. T is the input, x is going to be the period, c is going to be the answer. Always remember C is going to be the answer, and these are not going to be overwhelming for you. All right, so here's what's happening. Evaluate cosine 5 pi using its period as an aid. So notice 5 pi is positive, and just for the sake of this first example, I drew a little graphic here. Now look, if I go all the way around, how far did I go? 2 pi. What if I went all the way around again? That's another 2 pi. What if I just went a single pi? That's 5 pi. So, whatever ordered pair this is for just regular pi is going to be the t value that I need for 5 pi. 5 pi and regular pi are the same exact thing, because you can kind of think of these as zeros, but we need them to figure out where we're going to land after we go an amount over a single period. Let me show you how to set this up algebraically. All right, so I'm looking at 5 pi. So remember, 5 pi is my t value, and that is going to equal x plus c. What is x? X is a period of 2 pi. So I'm going to write 2 pi plus, that's not enough. I need to add another period of 2 pi. Remember, 2 pi plus 2 pi is 4 pi. Not enough. How much more would I add to get that? Pi. 2 pi, a complete circle, plus 2 pi, another complete circle, plus regular pi equals 5 pi. Just like combining like terms. This is where I'm going to grab the ordered pair, because the ordered pair for this matches this exactly. So if we want cosine of 5 pi, it is going to be the same exact value of cosine of plane pi. They're on the same exact spot on the coordinate grid. And remember, over here to the left side, remember this is -1, 0. And this is sine, and this is cosine, and that's sine. So cosine of 5 pi is just the x coordinate. It's just -1. That's going to be the answer. Okay, let's take a look at example 5. So for example 5, we're going to evaluate the trig function sine 13 pi over 6 using its period as an aid. Remember, period is a code word of 2 pi. But you got to be careful, because we're going to write 2 in terms of 6's. So think about what divided by 6 equals 2. And the answer, of course, is 12. So we're going to write 2 pi in like terms of 6's. So here we go. We're going to start out with 13 pi over 6. And we are going to write a period. Was 12 divided by 6? That. Now, do these equal? No, they do not. What do we have to add to it? Whatever we add to it is going to be the answer. So 12 plus what makes 13? Of course, it's going to be pi over 6. So if I'm looking for a sine of 13 pi over 6, it is the same exact value as this right here. Remember, pi over 6 is in the first quadrant. I know both of these are positive. And remember, if that ends in a 6, that's going to be root 3 over 2. And this one is going to be 1/2. So what is sine of 13 pi over 6? 1/2. That's it. That's the answer. All right, let's talk about this negative value. So for this negative value, I don't know if you noticed or not. Let me go back to here. I had two circles, so I had one going counterclockwise where it's positive. Here's a counterclockwise. So if I go down and go right back to where I started, that's negative 2 pi. Please remember, you can kind of consider this to be like quadrant 1, that kind of like quadrant 2, kind of like quadrant 3, and kind of like quadrant 4 when you're thinking about your reference angles. But let's keep that aside. You just remember when you go clockwise, every time you wrap around, it's negative 2 pi. Now, let's look at this. Let's go ahead and start it the same way we did here. Let's take that negative 7 pi over 2, and let's set it equal to something. What are we going to set it equal to? Negative 2 pi. But remember, we have to write it in terms of 2. What divided by 2 is negative 2? What's going to give us this value? The answer, of course, is negative 4. Now, if you notice, negative 4, that's one wraparound. I really want to get it as close as I can to negative 7. And for negatives, you always go over. Let me show you what I'm talking about. Let's add another negative 4 pi over 2. What is that? Negative 4 plus negative 4, that's negative 8 over 2. We went over. Now, what would I add to that to get it just to be a negative 7? You're going to add a positive pi over 2. This value is always positive. So what has happened? Let me go back to this. We wrapped around once. We wrapped around twice. Oh, that's too much. Let's back up a half. Where are we at now? Right here. This is pi over 2. Okay, so if I'm wanting cosine for negative 7 pi over 2, it's going to be the exact same cosine, the exact same x value as pi over 2. So negative 7 pi over 2, the cosine value for that, remember that's at the top of the circle, so it's 0.